Hello, welcome to the second part of our lecture on infinite limits and limits at infinity. So this time we'll be discussing limits at infinity. Now let's consider the function f of x equals to 1 over x. What happens as x increases or decreases without bound? So this time, yung x naman ang mag-i-increase or decrease without bound. So say x is 1, f of 1 is just 1. If x is 10, f of 10 or 1 over 10 is just 0.1. So if as you increase the value of x, as you increase the value of your denominator here, what is happening to the value of f of x? Okay, let's look at the other side. If x is negative 1, f of x is negative 1. If x is negative 100, yun, f of x is negative 0.01. So dito naman, nagdi-decrease yung value ng x. As you decrease the value of x, anong nangyayari sa value ng f of x? So in parang rough symbols, we say that as x approaches positive infinity, ito, as x approaches positive infinity, f of x seems to approach 0. Palit ng palit yung value niya. Though hindi siya magiging 0, palapit lang ng palapit yung value niya sa 0. On the other hand, as x approaches negative infinity, the value of f of x is also approaching 0. Tama? Okay. This is the graph of f equal to 1 over x. So as we have seen in the table of values earlier, as x approaches positive infinity, or as you increase the value of your x, tingnan nyo, yung value ng f of x natin, palapit ng palapit sa 0. X approaches negative infinity, the value of f of x, okay, yung f of x natin, diba, is approaching 0. Okay, so ito ulit, intuitive definition lang based on what we have illustrated earlier. So we say that the limit of f of x as x approaches positive infinity is L if the values of f of x get closer and closer to L as the values of x increase without bound. So in symbols, we say that the limit of f of x as x approaches positive infinity equals L. Okay? Habang ini-increase natin yung value ng x or the value of x increase without bound, palapit ng palapit yung f of x sa L. Sa value na L. Okay? Similarly, kung ina-approach naman natin or dinecrease natin without bound yung x, we say that we get the limit of f of x as x approaches negative infinity. Okay, so if you get a value, kung may nilalapitan na value yung f of x, we say that the limit of f of x as x approaches negative infinity is L. Okay, so yung illustration natin kanina, if we write it in those notations, we say that the limit of 1 over x as x approaches positive infinity is 0. Okay, so as x approaches positive infinity, yung value ng f of x ay palapit sa 0. So eto, this is how we write that. Sa table naman na to, as we decrease the value of x without bound, or yung value ng x ay papunta sa negative infinity, the value of f of x approaches 0. So we write that as the limit of 1 over x as x approaches negative infinity is 0. Okay? So yung sagot dito, yung limit natin, yun yung nilalapitan na value ng f of x as x approaches positive infinity or negative infinity. Okay? Kung kanina or dun sa previous lecture, dinefine natin yung vertical asymptotes. This time, we define the horizontal asymptotes. Again, this is a line, and a horizontal line has equation y equals a constant. In this case, we have y equals L. So that is a horizontal asymptote of the graph of y equals f of x if the limit of f of x as x approaches negative infinity is L. Okay, nasan yan? So, diba, as x approaches negative infinity, okay, yung function natin palapit dito sa y equals L. On the other hand, if you get the limit of f of x as x approaches positive infinity, and you have the value L, then we say that y equals L is a horizontal asymptote. Diba? As x approaches positive infinity, yung value ng f of x natin palapit dito sa value na L. Okay, so kung kanina, you have to check kung kailan nagsi-zero yung denominator, yun yung possible vertical asymptotes. This time, para maka-check or para makakuha ng horizontal asymptotes, kukunin nyo lang yung limit as x approaches negative infinity and positive infinity. If you go back to the graph or to our illustration earlier, diba? So, the limit of 1 over x as x approaches positive infinity is 0. Okay? The limit of 1 over x as x approaches negative infinity is 0. Therefore, we say that y equals 0. Okay, so itong y equals 0 is a horizontal asymptote. Ito na lang, y equals 0 is a horizontal asymptote of the graph of f of x equal to 1 over x. Okay? Now, if you go back to the limit theorems that you have maybe discussed a few meetings ago, we have these theorems. Ang sinasabi natin dito, bakit natin nire-review? Okay, di ba dati x approaching a? This time, those theorems hold kahit na ang x mo approaching plus or minus infinity. So, kung nag-e-exist yung limit ng f and g, then yung limit ng sum or difference nila as x approaches plus or minus infinity is still equal to the sum or difference of their limits. Ganun din, if you have a product, okay, so pwede nyo rin kunin yung limit as x approaches plus or minus infinity. So, i-multiply nyo lang yung limits ng dalawa. Okay, ganun din, if you have or if you want to get the limit of a constant times the function, this is equal to the constant times the limit of the function as x approaches plus or minus infinity. Ganun din pag division. Okay? Provided that L2 here is not equal to 0. So, ganun ha, yung previous theorems, limit theorems na na-discuss nyo dati, applicable din if you want x to approach plus or minus infinity. And so, if the limit of f of x as x approaches plus or minus infinity is L, and n is a natural number greater than 1, so sinasabi sa theorem na to, yun, pwede niyong ipasok yung limit or kunin muna yung limit ng function as x approaches plus or minus infinity and then raise it to n. Okay? Or if you want to get the limit of the nth root of f of x as x approaches plus or minus infinity, so pwedeng kunin nyo muna yung limit and then get the nth root. Ito, andun pa rin yung restriction natin na the limit or yung radical nyo should be greater than 0 when n is even. Okay? So, some quick examples. So, the limit of x as x approaches positive infinity is positive infinity. The limit of x as x approaches negative infinity is negative infinity. The limit of x squared as x approaches positive infinity, so you have positive infinity squared, that's equal to positive infinity. The limit of x squared as x approaches negative infinity, so you have negative infinity squared, any number square, ito kahit infinity, that will be positive infinity. Okay? Next, the limit of 6 as x approaches positive infinity, ano kaya? Diba, ang limit ng constant ay equal din sa constant. Ganun din, if you want to get the limit of pi as x approaches negative infinity, constant function din to. Okay, so this should be equal to pi. The limit of 1 over x as x approaches infinity, yan. So, kanina, di ba, pag meron kayong constant over 0, infinity yon. Ito naman, pag meron kayong 1 over infinity, nga 1, Dinivide nyo, tas ang dami-dami. So, that will be equal to 0. Ganun din, the limit of 1 over x as x approaches negative infinity is also 0. Okay, so in general, ito na yung mga theorems. If c is a real number, ang limit ng constant ay equal sa, as x approaches plus or minus infinity, equals sa constant. Okay, if n is even, nakita natin kanina, okay, kung ang exponent ng x ay even, so yung plus or minus infinity raised to an even exponent is always equal to positive infinity. If n is odd, kung odd tong exponent na to, naturally, a positive value raised to n exponent, positive pa rin. A negative value raised to an odd exponent, you get a negative value. So in this case, the limit of x to the n as x approaches negative infinity is negative infinity. And then ito, yun nga, useful tong part na to or yung item na to, the limit of 1 over x to the n as x approaches plus or minus infinity. Okay, 1 divided by a very, very big number, this is equal to 0. Okay, so pakitandaan yan ha. Now, if c is a real number, and suppose the limit of f of x as x approaches positive infinity is c, and the limit of g of x as x approaches positive infinity is plus or minus infinity. So, para ang sinasabi nito, you have a constant divided by plus or minus infinity. Okay, so a constant divided by plus or minus infinity is equal to 0. Okay? Yan, so yung x approaching infinity, dito sa number 5, ito kasi yung medyo, diba, medyo bago dun sa mga theorems. So you can replace yung x approaching positive infinity by x approaching a, x approaching a from the left, x approaching a from the right, and x approaching negative infinity. Basta when you're getting the limit, and yung limit ng numerator ay constant, ang limit ng denominator ay plus or minus infinity, then that's equal to, the limit is equal to 0. Okay? Sige, let's look at some examples. We want to get the limit of x to the 4th minus 2x cubed as x approaches positive infinity. Okay, baka i-substitute nyo agad. Sige, if you let x be equal to positive infinity, diba you get positive infinity raised to 4, positive infinity, minus 2 times positive infinity cubed, positive infinity. Okay, so kung ganito ay indeterminate form pa siya. Diba? So what can we do? You can factor out x with the highest exponent. In this case, ang highest exponent ni x ay 4. So, if you factor out x to the 4th, you get 1 minus, so 2x cubed divided by x to the 4th, you have 2 over x. Tama? The limit of x to the 4th, di ba pwede nating kunin yung limit ng bawat factor as x approaches positive infinity according to the theorem. So, limit ng x to the 4th as x approaches positive infinity is positive infinity times the quantity 1 minus, so ano ang limit ng 2 over x as x approaches positive infinity? Yan. So, you have 2 over infinity or 2 divided a very big number. Therefore, that part is equal to, yung limit niya is equal to 0. Okay? Yan. So, 1 minus 0 is 1 times infinity. So, you have positive infinity. Okay? So, hindi na siya indeterminate form. Ito, sure na tayo na positive infinity ang sagot. Okay, next, we want to get the limit of 3x raised to 5 minus x to the 4th plus 2x minus 4 as x approaches negative infinity. Again, if you substitute negative infinity, 3, negative infinity raised to 5 is negative infinity. Okay? So, that will be equal to negative infinity minus negative infinity raised to 4 is positive infinity. Plus 2 times negative infinity, ilan yan? Negative infinity minus 4. Okay, actually, ito pala, We have negative infinity, minus infinity, minus infinity, minus 4. Ito, hindi siya indeterminate form. So, pwede nyo na actually isagot na negative infinity. Okay? Pero kung gusto yung mas clear, baka nagdududa kayo, baka may mali kayo sa sign. Sige, gawin natin yung ginawa natin sa first example. You factor out x raised to 5. Okay, so ano yung magiging terms sa isang factor? You have 3 minus 1 over x plus 2 over x, ilan? X raised to 4 minus 4 over x raised to 5. Okay? And then, since yung x natin is approaching negative infinity, lahat ng constant over a power of x, ang limit niyan ay 0. Okay? Hindi siya equal to 0 ha. Yung limit ang equal to 0. So, the limit is 0, 0. Okay? So, what will you have left? Negative infinity raised to an odd exponent, 5, is equal to negative infinity. Okay? Times 3, that is still equal to negative infinity. Okay? So, kahit alin dyan sa solution na yan ay okay lang. Let's look at these other examples. We want to get the limit of 1 over x cubed minus 4x as x approaches positive infinity. Okay? If you immediately substitute yung positive infinity sa denominator, di ba, you'll have infinity minus infinity, which is an indeterminate form. So, gawin natin, katulad nga dun sa remarks, equal to. So, 1 over, factor out natin yung x cubed, 1 minus 4 over x squared. Okay? So, this part, ang limit ng 4 over x squared as x approaches infinity is 0. So, you just have limit of 1 over x cubed as x approaches positive infinity. This is 1 over positive infinity, which is equal to 0. If you factor out 3x squared and get the limit as x approaches negative infinity, okay, sige, okay lang kasama yung 3. So, you have 1, ay sige, alisin na natin. X squared na lang para hindi mahirap yung pag-factor. So, 3 minus 2 over x minus 5 over x to the 4th. Okay, so all terms with x in the denominator, ang limit niyan ay 0. Okay, the limit of this is 0. Limit is 0 as x approaches negative infinity. So, all we have is the limit of 3x squared as x approaches negative infinity. And negative infinity squared is positive. So, this is equal to positive infinity. Okay? Next, we want to evaluate the limit of x minus 1 over 3x plus 1 as x approaches positive infinity. Okay, sige, tingnan nga natin isa-isa. Diba, may theorem tayo na we can get the limit of the numerator and the denominator. Pero ano yung limit ng x minus 1? Ng numerator natin? As x approaches positive infinity. Diba, positive infinity minus 1, that's equal to positive infinity. On the other hand, kunin naman natin yung limit ng denominator as x approaches positive infinity. So, 3 times positive infinity is positive infinity plus 1, positive infinity pa rin. Yan. Paano yan? So, you have infinity over infinity. Sige, tingnan natin yung behavior ng x minus 1 over 3x plus 1. So, tingnan natin how you want x to approach positive infinity. Ano yung nangyayari when we are increasing the value of x? So, ito 0, f of 1 is 0, and then these are the other values. What do you notice? So, it seems that f of x is approaching what value as x approaches positive infinity? Parang it's approaching 0.333 or parang 1/3. How will we compute this value? Hindi naman pwedeng kukumputin nyo lahat ng values na to, tapos observe nyo, di ba? So, how will we compute the limit of x minus 1 over 3x plus 1 as x approaches positive infinity? Actually, yung infinity over infinity, that is, if the limit of f of x as x approaches a is infinity, and the limit of g of x as x approaches a is also infinity, is another indeterminate form. Okay, natatandaan nyo pa yung mga indeterminate form, ha? Babalikan ulit natin siya hanggang sa medyo bandang dulo na ng Math 21. Okay, so this is another indeterminate form of type infinity over infinity. Okay, pwedeng plus or minus infinity. Indeterminate form pa rin siya. Yan, so yung x approaching a, pwede nyo raw palitan ng x approaching a from the right, x approaching a from the left, x approaching infinity, and x approaching negative infinity. Okay, so what do we do if we have an indeterminate form of this type? So ang technique daw, we multiply the numerator and denominator by 1 over x to the n. Yan. Where n is the degree. Bakit may quotation yan? Kasi baka may radical. Remember, yung term na degree ay ina-apply natin sa polynomial. That's the highest exponent of x in the polynomial. Pero kung may radical ka, parang somehow may equivalent degree. Okay? So, get the highest exponent in the denominator. Highest exponent of x. Sige, let's illustrate that para mas makita nyo. So, we want to get the limit of x cubed minus 2x squared plus 3 all over 4x to the fourth minus x squared plus x plus 1 as x approaches positive infinity. Diba, kung kukunin natin yung limit ng numerator as x approaches infinity, remember, sabi natin kanina, kunin nyo lang yung limit ng leading term, in this case, x cubed. So, limit ng x cubed as x approaches positive infinity is infinity. Okay, so scratch muna. Positive infinity, tapos sa denominator din. So, ang highest exponent ng x sa denominator ay 4. So, limit ng x to the fourth as x approaches positive infinity is also positive infinity. Indeterminate form yan. So, what do we do? According to the technique that was mentioned earlier, we multiply the numerator and denominator, sorry, dito ko na lang ilalagay, by 1 over x, where x is raised to the degree of the denominator. Yung highest exponent sa denominator, in this case, ay 4. Okay? So, you multiply by 1 over x to the fourth over 1 over x to the fourth. Okay? Dapat partner yan, ha? Para equal to 1 pa rin yung minumultiply natin. Hindi natin binabago yung given. Okay? Yan. Sige, so, multiply natin. Get the limit as x approaches positive infinity. Okay, distribute 1 over x to the fourth to each of the terms in the numerator. So, you get 1. Sige, pa-double check ha. 1 over x minus 2 over x squared plus 3 over x to the fourth. Agree? Okay? Sa denominator din, so we distribute or multiply each of the terms by 1 over x to the fourth. Parang i-divide natin by x to the fourth yung bawat term. So, you have 4 minus 1 over x squared plus 1 over x cubed plus 1 over x to the fourth. Okay? So, bakit natin kinailangan gawin yon? Notice na nung minultiply natin by 1 over x to the fourth yung numerator and denominator, nagkaroon tayo ng mga terms na may x sa denominator. And kung kinukuha natin yung limit as x approaches infinity, tapos may x pa kayo sa denominator, ano yung nakita natin kanina? Ang limit nito as x approaches infinity is 0. Okay, you have a very big number, or 1 divided by a very big number approaches 0. Okay? Yan. So, lahat ng may x pa sa denominator approaches 0. Ano na lang naiwan? So, 0 plus 0 plus 0, you have 0 in the numerator, and in the denominator, you have 4 plus 0, or 4. And 0 divided by 4 is 0. Okay, so this is our limit. Naalala nyo pa yung absolute value function? Remember, the absolute value function can be defined in two ways. Yung piecewise definition niya, and you can also write it dito in terms of the square root definition, or the absolute value of x is equal to the square root of x squared. Now, two things can happen. As x approaches positive infinity, okay, so kung yung x mo papunta sa positive infinity, definitely greater than 0 yon. So yung square root of x squared will be equal to x. Okay? Sorry, nawalan ng space. So yung x squared mo is equal to x as x approaches positive infinity. Nakuha? On the other hand, kung yung x mo naman ay approaching negative infinity, diba? From the piecewise definition, ito yung titingnan natin. Kasi x is definitely less than 0. It's approaching negative infinity. So yung square root of x squared, as x approaches negative infinity, is negative x. Okay, sulat ko na lang dito. Square root of x squared equals negative x as x approaches negative infinity. Okay? So, gagamitin natin to pag may mga radicals dun sa kinukuhanan natin ng limit. For example, we want to evaluate the limit of the square root of x squared minus 3 over x plus 2 as x approaches positive infinity. If you substitute infinity, so infinity minus 3, you have infinity. Square root of infinity is still infinity. So infinity over infinity plus 2, infinity. Indeterminate form siya, kaya i-multiply natin by, technically, di ba, we have to multiply by 1 over x raised to the highest exponent of x in the denominator, which is 1. 1 over x. Okay? Pero ang problema natin ay meron tayong square root. Okay. So, dito sa part na may square root, syempre, di ba pag nagmumultiply tayo ng radicals, we can multiply the terms under one radical provided that they have the same index. So, express din natin to as a radical. Or multiply this by 1 over the square root of x squared. 1 over the square root of x squared. Okay? And since x is approaching positive infinity, okay, yung square root of x squared is equal to positive x. Okay, so let's rewrite that. So yung may square root, ang gagamitin natin na multiplier ay 1 over square root of x squared. Pero sa denominator, okay na yung 1 over x. Again, positive x to. Positive x. Kasi x is approaching positive infinity. Okay, so now we can multiply inside the radical sign. You can write this as x squared over x squared. Tama? Minus 3 over x squared. All over x is 1 plus 2 over x. So, get the limit as x approaches positive infinity. Again, yung may mga x pa sa denominator, the limit is equal to 0. Okay? So, what remains is square root of 1, which is 1, divided by 1, 1 over 1, and this is equal to 1. Okay? Let's look at another example. Now, suppose we want to get the limit of the square root of 9x squared minus x plus 3x as x approaches negative infinity. Okay, pero let's check ano yung pwede nating gawin. Ano pa yung pwedeng gawin dito? Okay, kung gagawin natin yung suggested technique kanina, wala tayong term sa denominator. Okay, kung gusto yung magkaroon ng term sa denominator, we multiply this by the conjugate of the numerator. So that's square root of 9x squared minus x minus 3x all over square root of 9x squared minus x minus 3x. So get the limit as x approaches negative infinity in the numerator. So you just square the first term, mawawala yung square root minus 9x squared all over the square root of 9x squared minus x minus 3x. So magka-cancel to. Yan. So we can multiply by 1 over yan, yung highest exponent sa denominator ay x or square root of x squared. 1 over square root of x squared. Okay? But since x is approaching negative infinity, okay, yung square root of x squared is equal to negative x. Okay, because x is approaching negative infinity. Yan. So we can now write this as, so yung 1 over square root of x squared is negative 1 over x. Okay? So, negative 1 over x ang gagamitin natin for the terms outside the radical sign. Okay? Yan. So, what you have is, so negative 1 over x times negative x, that will be positive 1. Okay? Then, negative, ito, may radical tayo. So, ang ipapasok natin, gagamitin natin yung 1 over square root of x squared. So, you have 9 minus 1 over x. Okay? And for this term na wala sa loob ng square root, we will be using negative 1 over x. So, negative 1 over x times negative 3, you'll have positive 3. Okay? So, this will be equal to 1 over square root of 9 is 3 plus 3, that's 1 over 6. Okay, so that's the end. That's the last example. But, of course, to check if you understood our lesson for today, yung mga indeterminate forms, paano kumuha ng limit as x approaches plus or minus infinity, you can try answering these exercises. So, thank you for listening. See you again next time.